This is a simple demonstration of how to enact adversarial perturbation attacks on a real world machine learning system. As you can get to see, this is basically a Google Docs screen. Google Docs is powered by a whole suite of machine learning models. The more popular ones that you might know of is the one that powers speech to text. So, for example, let me try this out. Hello, one, two, three. The other machine learning model that few people might know about is the one that powers the glyph to characters that can be accessed through insert special characters. And now let me kind of type out a specific glyph here. So this is basically two. And what you get to see are the candidate classes. I'm guessing that this was basically trained on the Unicode dataset where you kind of scribble out a symbol here and you'll get a bunch of results in descending order. So this is the most probable one, followed by the other options. And as we kind of go down the pecking order, you'll see the less probable options. And it works remarkably well with regards to the entirety of the Unicode dataset. Like this is basically the Kannada glyph for 4, and you'll get to see, in fact, that is in fact the best predicted class. Now going back to, let us say, this which is basically 2. Now the question is, what are these adversarial perturbations, and how do we carry out this adversarial perturbation attack? So we introduce small inconspicuous changes to the glyph that we just drew here, or the symbol that we just drew here, and you'll get to see a rather dramatic change in the label space that the machine learning model has predicted. So let me, just introducing this, basically introduce this character in here, and let me introduce another small adversarial perturbation, and you see the emergence of completely different set of glyphs here. And as we kind of add these, you'll get to see that the top predicted character is this ideograph that looks absolutely nothing like this. So as we kind of add more dots in here, it has completely moved into a whole different realm of labels. And this is basically how adversarial this is how potent adversarial perturbations really are.